Hello, Viraj. How are
Hi,
you?
sir. Hi, sir. I'm fine. How are you, sir?
I'm fine. You don't look fine. Have you not recovered?
No, no, I have recovered. I'm almost fine. Yeah.
Good, good. Do you want a session today?
Yes, sir. We'll just have a session today because काफी gap हो गई है बीच में.
गैप की टेंशन मत लो. Navigation is something where you need to be alert. So,
Yes,
जो
sir.
पढ़ रहे
True.
हो सिर के ऊपर से नहीं जाना चाहिए.
Yes, sir. So we'll just have a session today. Yeah.
चलो, तो revise all that we have done
I
so
did a
far.
bit.
Go
I
through your
did a bit.
notes.
Yeah.
We will start in a minute
Uh,
or two. See if you have
yes,
any
sir.
questions.
Okay. Yeah.
What did we learn the other day? We learned how to convert hours into minutes.
Yes,
Then
sir.
uh,
Then we did RAM rise also.
RAM rise is the
Fuel flow.
difference between the total air temperature and
Total
the
and
static air
the
temperature.
static air temperature. Yes.
Static air temperature is required to measure true air speed and pressure altitude.
Pressure altitude. Yeah.
TAS from CAS and pressure altitude, or calculate TAS from Mach number.
Yes, sir.
Have you written these points down?
Yes, I have written this. I have not written this actually. I have written a bit. So what I'll do, I'll just rejoin the session because the loading sign is coming. I don't know what is happening.
Sure, join us.
Yeah. Yeah.
I have two. Okay, now
Yes, sir. Now it is fine. Yeah.
so give me an overview on all the concepts that you have understood so far in navigation.
So yeah, we started with the directions. So Earth has four major directions, as you told me: north, south, east, west. And the globe currently which we are using is World's Geodetic Society 1984, that is WGS 84. And there are the main directions are also known as cardinal points, which is 000 degrees, 3 degrees north. East it is 090 degrees, south it is 180 degrees, and west it is 270 degrees. Then you told me about the thumb rules, that is CDMVT. So Earth basically has a true north, and Earth also
True north is
has a magnetic
geographically fixed.
yeah. True
And
north is
magnetic north
geographical.
is that north the axis
Magnetic
of
north
which is the rotation axis.
is the rotation axis, as is it, and as it is tilted, so the magnetic north doesn't stay
It
in its
keeps
place.
changing its
Actually, it
position.
yeah. And right now it is somewhere in Russia, and then there is compass north. So compass north is basically the the north of the compass, which gets deviates
No, no.
by
It is
the
the north.
by the
It is the north
aircraft.
from the
Yeah,
compass reading, accounting for the deviation, which is the aircraft, which is
deviation,
because of aircraft magnetism.
aircraft magnetism.
The
Yeah,
north in which the compass
and
points accounted for deviation due to aircraft magnetism.
aircraft. Yeah,
We correct deviation to get magnetic direction, and we correct magnetic direction for variation. So you did not say variation. Variation, the
variation.
difference
Yes,
between true north and magnetic north.
yes. And after
Deviation is
that,
the
we
difference
did
between deviation is difference between
deviation
compass north and magnetic.
is the difference between, yes, CDMBT, yes. And after that, we did the magnetic depangle. And depangle is basically
Due to
magnetic
the
depangle
vertical
is,
component of Earth's magnetism.
yes, yes,
Correct? On the equator, it is
yeah.
0. Poles, it is 90 degrees. That is maximum.
It 90-degree, yes.
So
And
it is not a good thing. It opposes the directional ability of a compass. The directive force of a
yes,
compass is horizontal
the horizontal,
magnetic.
yeah, yes, sir.
Very
Horizontal
good.
magnet,
Very good.
yeah.
Very
And at equator, the horizontal component is very low.
high.
It
Equator?
high, yeah.
High, high.
Uh, on equator, the horizontal component is maximum, and poles it is very low. Okay. And after that, we did equator. So equator is basically a great circle which divides Earth into two equal parts or two equal hemisphere. And equator is a latitude with 0 degree north and south. And then there are parallel latitudes of equator which become smaller as we go towards the poles.
Say again after equator.
And after that, we did. So, sir, equator is a great circle which divides Earth into two equal parts or two equal hemispheres. Equator is a latitude with 0 degree north and south, and there are parallel latitudes of equator which become smaller when we go towards the poles.
Becomes smaller. The
Yeah,
length of the circle becomes small. Okay.
E- the
Okay.
length, yeah.
Circumference. Okay. Correct. Very good.
And after that, we did the velocity triangle.
Very good. We also did meridians,
In velocity,
longitudes, meridians, longitudes.
yes,
But
yes, sir.
that
We
we
also
did
did meridians
after
long
that probably
after
we did
velocity
after
triangle, I
velocity
guess.
transfer.
Yes, so we did velocity triangles. You told me that what is drift. So, if when I'm given when my aircraft is given a true heading, and my aircraft deviates from its true heading to a track mid go due to the wind components. No, due to the wind velocity, it is known as drift. So,
No,
and
drift is the angular difference between.
angular difference between the one second, sir. The true heading and the track mid good.
Don't say true heading and the track made good. Mm, drift require track and track made good.
Yeah, yeah. Required track and track mid good.
Heading could be different. So you don't use
Yes,
heading
sir.
in your drift. You say
Yes, sir.
require track and track made
Required
good.
track and the
That
track
is the
mid good.
drift angle. And now
Yeah,
you change your heading to be on the required track.
to
So
be
always remember,
required.
don't say true heading, say required track. When you have zero winds, that time your required track and your heading is the same. The moment you start getting
Yes, sir.
winds, if you maintain your heading, your track changes. This change in the track is
Yes,
known
sir.
as drift. So then you can say drift is aircraft heading, drift is
Aircraft heading.
angular
Yes,
distance from aircraft heading to the deviated track.
yes, sir.
To the deviated track, aircraft
To
heading
the
and the
deviated
deviated
track.
track. How do we see it? We will see it with the diagram. So in zero wind, our aircraft is flying like this.
Yes, sir.
Okay. So its heading is this 0, 0, 0, and its required track is also this 0, 0, 0.
Yes, sir.
Good. The moment we start getting wind from the
Wind. From
port
the
side.
port side, yeah, port side.
Port side. What
Yeah,
happens? This will push the aircraft on the starboard side,
on the
causing it
starboard
to
side,
drift
yeah.
away from the required.
Drift. Yes, sir.
Now the pilot is required. The pilot can control the heading of the airplane, so he tries to maintain the same heading, 0, 0, 0. But because of the wind component, there is a new track which the aircraft takes, which is this,
Yes, sir.
maintaining the same heading. So if I had to change the aircraft,
We'll just turn opposite to the, yeah.
see like this. So the aircraft will be maintaining the same heading, but it will be on a deviated track.
Yes, sir.
So the heading is still the same, but the track is different. If I don't
Different.
correct this, then what will happen is the aircraft will keep deviating.
Deviating, yes, sir.
And the pilot is doing the right thing. The pilot knows that, okay, I have to maintain the heading. And see how far he has reached. He had to reach over here. He was supposed to be
Yes,
here.
sir. Yes, sir.
He was supposed to be here. But because of the drift, so drift is the angular difference between the aircraft heading
Between,
and the
yes, sir. Track made good.
drift. What do you say?
Track made good.
Track made good. You could say that track made good.
So
So what will the pilot do? In order to
he,
in order to maintain the required track, he'll have to
yes,
change his heading. So right now,
yes, sir.
if the difference between the required track and the track made good is say 20
Yes, sir.
degrees, okay, towards the
Yeah.
starboard side, it means I have to turn left 20
Turn
degrees
left 20
for my
degrees. Yes,
heading.
sir.
For my heading. So what will I do? I will take this aeroplane and I'll change its heading
Yes, sir.
by 20 degrees. Okay.
Yes, sir.
So the concept
So
is
we'll
clear.
turn port.
You
Yeah,
can
yeah, yes,
decide.
it is clear.
So
Yes, sir.
in the examinations, you will be given a question where the aircraft is allowing for the drift. Remember. So if the aircraft has
Okay.
its heading on the left side, it means the drift was starboard.
Starboard, yeah.
If the heading is on the left side of the required track, then it's starboard drift. It's opposite to what it
Starboard.
seems.
Opposite.
Remember, okay?
Yes, sir. Yes, sir.
Good. So what else? Go through your notes.
So after that we did uh, after that we did the meridians and the latitudes. So you told me that the Earth shape is oblate spheroid, and it means that Earth is compressed at poles, reducing the length of polar diameter compared to the equatorial diameter. Hence, the equatorial diameter is known as major axis, and the polar diameter is known as minor axis. And then there is compression ratio is basically the relationship between Earth's minor axis and Earth's major axis, and also there is a ratio of ellipticity, and 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 the formula for that is minor axis upon major axis minus minor axis. And after that, the compression ratio of Earth is 0.3%, that is 1 by 300. And major axis minus minor axis will be 43 kilometers or 23 nautical miles.
Or
And after that,
27
you
statute
told,
mines.
oh yeah, or 27 statute of mines. After that, you told me how the kilometer was made basically. How
A kilometer
was
quantified
yeah,
basically.
yeah, quantified. So 1 kilometer is defined as a one as a 1 by 10,000th part of the Earth distance from the pole to the equator.
So
Yeah,
one
and then
kilometer is
you
the 10,000th part of the
ten
distance
thousandth of
from the pole to the equator.
pole to equator. Yes, sir.
Very good. I'm
And after
impressed.
that, you told me what is graticules. So graticules is basically a system of longitudes and latitudes to help determine the position fixed on Earth. And you showed me Earth in four different angles. It was rear, front, top, and bottom. And then we did this
What is the
some,
motion of
and
Earth when
then
viewed from South Pole, viewed from North Pole, clockwise, anti-clockwise, and you also have to define meridian.
yes, sir. Okay. Mm, So I think I didn't copy that. 1 second.
Meridian, semicircles joining
Uh,
from the North Pole to the South
Semicircles
Pole.
joining. Yes, 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 yes.
Every meridian has its anti-meridian.
Every
Together,
and
meridian,
anti-meridian.
anti-meridian together a longitude. All longitudes are
Yes, sir.
semicircles.
Yes, sir.
Is the meridian passing through Greenwich, London, which is known as prime meridian, and
Prime
it divides
meridian.
the Earth
Yeah.
in two equal hemispheres, Eastern
Two
Hemisphere and
equal
Western Hemisphere.
hemisphere and Western hemisphere. Yeah.
Don't forget this, and then you can calculate D long and D latitude.
D
You know
long
how
and
to
D lat. That
calculate
is
D long
changed
and D
in.
latitude.
Yes, yes, sir. Yes, sir. Done, sir. Then we did fuel flow. And then you told me the ratio when we'll go from minute to hours, it will be multiplied by 60, and hours to minute will be divided by 60. That is a thumb rule for the fuel flow. For the time actually to how to calculate time. And then we did some fuel flow. I do not remember ram rise अच्छे से. Can you just repeat that?
अभी बताया तो था रैम टाइप्स. ट्राई करो रिकलेक्ट
Yes,
करने
sir,
का.
आपने बताया से मेरा ध्यान. Ram rise is basically mm, total air temperature minus static air temperature.
Air
Okay.
temperature due to the flow
Mm,
of the air when aircraft is moving due to the dynamic pressure
okay.
basically there is an increase in the static air temperature.
Static air temperature. Yes.
It is an irregularity. When there is no irregularity there will be no ram rise.
Yes, sir.
Write down ram rise quickly.
Yes, sir. Yes, sir.
Okay. Ram rise formula is stat minus sat. So actually you need sat to give you tas from cas. You
As
need
from
sat to
gas.
give you pressure altitude and you need sat to give you tas from Mach number. Do
Okay.
you know the full forms?
Yes, sir.
Total air temperature, static air temperature,
Static air
total
temperature,
true airspeed from calibrated
true air
airspeed,
speed, pressure altitude.
true airspeed from calibrated
Uh,
airspeed,
yes, sir.
and to calculate TAS from Mach number.
That's from Mach number.
What we measure from the temperature probe is the TAT. Remember this. What we measure from the temperature probe, the sensing element to measure temperature, is actually the TAT. It is not the SAT. Remember, this is a
Okay.
very important question.
Okay.
What we measure from the temperature probe is the TAT.
Is it at? Yeah.
Temperature probe measures TAT.
Yes, sir.
What is TAT affected by? TAT is affected by compressibility and kinetic or adiabatic heating.
Hitting.
So
Okay.
TAT is, these are two terms you have to keep in here.
Yes, sir.
TAT is affected by compressibility
Compressibility.
kinetic or adiabatic or adiabatic heating.
Yes, sir. Yeah.
This is why we have an increase in the temperature.
Yes, sir.
That is always higher than SAT. That's why. Okay.
Yes, sir. Yes, sir.
Therefore, if I want SAT, then I will get uh, SAT is smaller than TAT. Like this, TAT is always greater than SAT. Now write down the formula for RAM rise.
Yes, sir.
RAM rise is equal to TAS upon 100 square.
Okay.
TAS is in knots. Write down this formula. All the formulas that you are writing, you make a big block
Yes, sir.
with some color pen or something, because in the end you will need a rest of these formulas. So now you know the
Yes.
formula of RAM rise from TAS.
Yeah.
Using this formula, TAS RAM rise, you can easily find out TAT.
Yes, sir.
So what is the RAM rise? If your TAS is 400 knots, solve this. If TAS is 400 knots,
Hmm.
RAM rise,
So,
I'm
one.
sorry.
Yes.
You have a formula for RAM rise?
Yes, sir.
Use your scientific calci.
Yes, sir. It will be 16,
Say again.
1616
16 degrees Celsius.
Celsius. Okay.
Approximately. This is an approximate answer.
Yeah.
What if the TAS is 500?
25.
Very good. Where are you doing this? Scientific calci or nav calci?
So, yeah. Scientific calci.
Very good. Correct. Your answers are correct. Now tell me, suppose TAS is 400 knots.
400 knots, sir, again.
Yeah, suppose TAS is 400 knots. RAM rise is 17 degrees Celsius.
Okay, yeah.
17 degrees. If that at 400 knots is minus 22 degrees Celsius. Remember, TAT.
Hmm.
What is the value of SAT? To find SAT.
So suppose TAS
The
was 400, RAM is 17.
RAM rise
Okay.
is equal to TAT minus SAT. So if you want SAT,
Yes, sir.
you have the RAM rise, you have the TAT, all you need is SAT.
Yes, sir.
As TAT is always higher.
Yes, sir. Mm, RAM is equal to, I have RAM rise. Okay.
So TAT is minus 22. Very simple. You
Okay.
have to
Minus
subtract
22.
you have
Yes.
to subtract
Yes,
17
sir.
from minus 22.
722. Yes, sir.
Use a scientific calculus simply.
Yes, sir. It will be 39 degrees.
Positive or negative?
Negative, negative.
Be careful giving your answers.
Yes, sir. Yes, sir.
Minus 39 degrees Celsius. SAT. Now you have your SAT. You can put the value of
Yes,
SAT
sir.
into your formulas or scientific calculus to find out your true airspeed or something like that.
Yes, sir.
This is TAS. TAS at 400 knots. If okay, this is TAT. TAT at 400 knots is okay. Easy. Now find the same
Yes, sir.
options in your nav calci.
In my napkin, if you want.
Yes.
Mm, So, gas, OAT, test, test. So in airspeed, there is TAS, OAT, MAC, TAT, CAS, and pressure altitude.
Yeah.
But SAT,
Solve this equation using nav calci.
okay, yeah. This, hmm, hmm. So how you solve? Can you just tell me?
All you need to do is feed in the values. Put TAT, put TAS, put RAM rise, and you will get your SAT.
Okay, yeah. Mm, so I'll go in airspeed, okay,
Say again.
and that will be
Say again.
4. I'll go in airspeed, right?
Yeah. Check,
I'll go
check.
in airspeed, and then total air temperature is minus 17, minus 22. Sorry. Uh, so how will I write minus 22 in TAG because it is
There
not
is a
coming.
minus sign. There is a minus sign on the keypad.
Oh yes, 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 there is.
Are you able to feed in?
Yes, 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 yes. I am.
Very good.
And so I had TAS.
TAS is 400 knots.
Yes, sir. That is that is. Mm, so I do not get this. See, TAS
Show
was
me, show me,
400.
show me on the screen. TAS 400 outside air temperature is actually SAT. Okay. So you
Okay,
need to find the
okay.
SAT. Okay. Show me the calci.
Yeah.
Yeah. So this you have to find. MAC you don't have. You have TAT. Okay.
Yes, sir.
So
Yes, sir.
just try putting in TAT and OAT. And what you're getting is minus 43, which is not accurate. Show me the calci once again. TAS 400. So put MAC will automatically come. Okay. Go back and see if you have more temperature related options. You need something for
Mm,
RAM rise.
one second, sir. Mm, no, sir. Wind correction, no. Hung line, no. Holding pattern, no. No, sir. Airspeed, standard atmosphere. The way- No, sir. Only in airspeed it is given. One second. Mm. So, what was our answer?
Minus 39.
Mm, 39. Okay. One second.
There might be a possibility that the
400.
calci, there might be a possibility that the calci uh, won't have that option, but only after you have checked all options that you can say that the calci does not have that option.
Yes, sir. OIT is minus 43 only. Minus 43 degrees Celsius OIT and TAS is
So
minus 22.
if if you have that, see in that question RAM rise was given to you. So if you have TAT and if you
Yes,
have
sir.
RAM rise, all you have to do is minus the RAM rise from the TAT to get SAT. Are you
Yes,
following?
sir.
Yeah.
Yes, sir. Yes, sir, I am.
Okay. So altitude, jet standard. Yeah.
So, what if in exam both the options are given like minus 43 also and minus 39 also?
It depends if they have given you RAM rise in the question. If they haven't given you
Okay.
RAM rise in the question, then answer will be 39. If they have not given you RAM rise
Okay.
in the question, then your answer will be 43, which is your NAP Calci
43.
answer. Common sense.
Yes, sir.
Okay, very good.
Yes, sir.
Good question.
Yeah.
Okay, good. Good. Okay, so now uh, Now we'll do more miscellaneous calculations.
Yes.
Fuel consumption. I'm sorry. Fuel consumption, and then we have uh, fuel flow, change of volume into weight, weight into volume. It is very easy.
Yes, sir.
Then conversion of distance. I'll show you what is weight, weight to volume. These are very simple sums. These you will get in your calci also. Okay.
Yes.
Uh, yeah, these are simple sums. So we'll take a break, and after that we'll continue. Take a five
Yes, sir.
ten minute breather and join a fresh
Yes.
session. Okay. Around
Yeah, yeah.
4:05, 4:07.
So should I exit session?
No, I'll end the session. We'll rejoin.
Okay,
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 fine.
sure.